This is Unit 6, Day 7, Part 2. Alright, so we were just testing 1. So store 1 in your calculator. And then, again, enter the whole thing in. So I'm just going 1, store X. And then go up and highlight the one you already typed in this whole big thing. So you're substituting a 1 in. And when I substitute a 1 in, I get 0. So again, I get 0, and is it less than 0? The answer is no. Oops, this one was a yes. Sorry, I forgot to write that. So that means it's not included. So you do not shade that. So far, we have only the numbers in between -4 and 1, but not including it. You're going to do the same. You got to still test 2. You got to still test 4. So when I test 2 stored as X, go to your calculator, and then go back up and highlight the whole thing. And when I store 2, I get a value of 6. Is 6 less than 0? No, that's not true. So that means all the numbers in between 1 and 3 are also a no. Okay? And then the last one I have to test here is above 3, which I chose 4. So 4 stored as X. So I'm putting that in my calculator. Go and highlight it, and it's like substituting a 4 in wherever you saw an X. And when I do that, I get 24. So is 24 less than 0? The answer is no. So there's a no up here. So if you guys pay attention, this is the only area that it is true for the test values. So in set notation, it would be for all X such that, and it's between -4 and +1, but not including them. So it's not equal to. Interval notation, it's sandwiched between -4, positive and +1, smooth parentheses because neither are included. So here's my set, here's my interval. Okay? So long process, not hard. Calculator will do a lot of your work. The only thing it really stinks about B and C, which is our last 2 examples, it's not set equal to 0. So what do you have to do? Turn it to an equal sign. Oops. And what you're doing is you're solving for X. How do I solve for X? Think of it as putting it over 1 and cross multiplying. So 1 times X is X. Okay? And then when I cross multiply the 5 and the X minus 8, I'm going to get 5X minus 40. Again, you need to set it equal to 0 and solve. So this is my numerator. Don't forget, guys, this is me doing the numerator. So when I do the numerator, I would minus this X from both sides. And then I'm going to get 0 equals 4X minus 40. And then hopefully you guys recognize that that's a GCF. Okay, so when I factor out a 4 from both sides, I'm left with X minus 10. Split, 0 equals 4, rejected, doesn't make sense. I get X equals positive 10. So the numerator only gives me a value of X equals positive 10. For the denominator, and remember the denominator is like making it undefined, the denominator is X minus 8. I set that equal to 0. That's when X is positive 8. So my critical values that I'm going to include on the number line are going to be, I don't know why I have it so long, are going to be positive 8 and positive 10. Okay? Positive 8 and positive 10. Where it is undefined, which is 8, is always an open circle. Okay? You have to test and see if 10 works. So we'll test that in a minute to decide if that's an open or a closed circle. So 10 is going to definitely have a circle. We're going to test it in a minute to see if it's open or closed. But then I got to pick test values. So 9 seems pretty logical to pick. And then maybe test like 11. It's 1 above it. And then test 7. That's 1 below it. So don't forget. We are testing 7, 9, 11. But don't forget we have to test 10 to see if we include it. Never include the undefined. So that one definitely stays open. Okay, so again, in my calculator, let's do the 10 first so we don't forget it. So I'm going to go 10 stored as X, but then I do have to put this original one in, okay? So when I put the original one in here, I'm testing out 10, but back to the original. So I'm going to put in start a fraction, And then I'm going to put this in. I'm going to put 10. Oops, not 10. Put x, because we already have it stored. X divided by x minus 8. Okay? I get 5. So when I test 10, I get 5. So let me write 10, stored it as x. I get 5. Is 5 less than or equal to 5? Going back here to this original inequality. The answer is yes. So that means you would shade the 10 in. Okay? It's included because that one worked. Alright, now I'm going to do the same thing. I'm going to store 7. So 7, store x. 7, store x. And then go back up and highlight this fraction in your calculator, which is x divided by x minus 8. And you get negative 7. So is negative 7 less than or equal to 5? Yes, that's true. What does that mean? That it's a yes in this area. If it's a yes in that area, that means it will extend this way. Okay, now I'm going to test 9. 9 stored as x in my calculator. Go in and highlight x over x minus 8. I get 9. Is 9 less than or equal to 5? No, which means that anything in between 8 and 10 is a no, so you don't connect them. The last value to test is 11. 11 stored as x. Again, if you don't know what I'm talking about with store, then you're doing it by hand where you're going to come up here and you're going to plug in 11. So you're going to do 11 divided by 11 minus 8. So it's going to be 11 over 3. Okay. And 11 over 3, if you were to get its decimal value. So this ends up being 11 thirds. Is it less than or equal to 5? 11 thirds is 3.6 repeated. Is it less than or equal to 5? The answer is yes. Okay. So you get a yes up here. What does that mean? All the values to the right of 10 is included. So my set notation, it's going to be for all x such that, and you're going to read this one over here, x is less than 8 or x is greater than or equal to 10. Okay, that's set notation. Interval notation. You're at negative infinity going up to positive 8, not including each, or union symbol, starting at 10, square bracket, it's included, all the way to positive infinity. Okay, last one here, a little hard. Okay, so you have to set it equal to 0. So change your inequality that you have, and again, this is for the numerator. And you're going to get your x minus 1 over x plus 2 over x plus 3, set it equal to 3/2. So in your head, this is kind of what we learned yesterday. You're going to say, how do I solve a fractional equation? You're going to multiply it by the LCD. What is the LCD? You want one of all of these. So my LCD is I need 2, I need x, so that's 2x. So let me make a little note up here. My LCD would be I need a 2, I need an x, and I need the x plus 3. So there's my LCD. So I'm going to multiply all of these by 2x, x plus 3. Okay, and then the middle one, 2x, x plus 3. And then the last one, let me move my LCD over. I'll just put that equals LCD over here. It's 2x, x plus 3. To make life easier, we kind of put them all over ones. And then you cross off and cancel anything you don't need. And again, it's kind of like the same lesson as the fractional equations. Sorry, guys, I'm kind of scrunched here. All right, so now this one, the x's cancel. Okay, so what do I really have here? I have 2 times x plus 3. So 2 times x plus 3 is 2x plus 6, right? That's right here in red. And then I have to multiply that times my x minus 1. Okay, I'll do that work in a minute. In the middle one, the x plus 3's go. So I really have this 2x that's right here. And I have to multiply by the x plus 2. And again, I'll do the work in a minute. And then the last one that really, really stinks is that the only thing that cancels are the 2's. So if I distribute this right here, I really have x squared plus 3x, but that's being times by the 3 right here from the beginning, this one right here. Okay, so now I got to clean that craziness up. So if I FOIL that, I'm going to get 2x squared. My outers would be negative 2. My inners are positive 6. That's a positive 4x. And my last would be negative 6. So this came from me just FOILing this. The middle term is going to be 2x squared plus 4x. And then that's equal to me distributing the 3, which is 3x squared plus 9x. Now I have to clean this up, combine like terms. So 2x squared plus 2x squared, I'm going to get 4x squared. And then I have a positive 4x and another positive 4x, which would be positive 8x. And then I have this minus 6. And that's equal to 3x squared plus 9x. All right. You should be thinking trinomial at this stage, and you want to bring everything to one side. Keep your x squared positive. So I'm going to move over the 3x squared. Okay. I'm also going to move over the minus 9x at the same time. And then I'm going to have a nice trinomial. 4x squared minus 3x squared would be 1x squared. 8 take away 9 is negative 1, and then I carry down the minus 6 equals 0. Okay? You know the part that really stinks, guys? All of this work is just to get the critical values for the numerator, which totally stinks. Okay? So, factoring this, I'm going to get x minus 3 and x plus 2. Split, x is positive 3, x is negative 2. Those are two of my critical values. The nice thing about the denominator, because I'm out of space here, actually, can you guys see this? I think you can down here. Okay, the denominator is what makes them undefined. The only one that makes them undefined up here is a 0 and a negative 3. So when x is 0 and when x is negative 3, it's undefined. So I have 4 critical values here that have to go on the number line. Okay, so here's my number line. Don't forget to put them in order from least to greatest. So I have a negative 3. It's an undefined, so it's definitely an open circle. I have a negative 2. I have to test to see if it's an open circle from here. I have 0. That's an undefined value, so that's an open circle. And then I have positive 3. Again, testing to see. So don't forget, you do have to test those to decide if they're open or closed. Okay? And then you want to pick numbers. Okay? So here's the thing that stinks. You might say, well, what's between negative 2 and negative 3? You might pick negative 2.5. Okay? That will be a test value. What's to this side? Negative 4. That's a test value. Okay? What's between 0 and negative 2? You could pick negative 1. That's a test value. What's between 0 and 3? 1. That can be a test value. And then last but not least, what's greater than 3? I'll pick 4. That's a test value. So you have 1, 2, 3, 4, 5 that's in blue, but you still have to test negative 2 and 3. Okay? How do you do that? I've explained it the whole way, guys. Use your store key. Yes, you're going to have to put this whole thing in and do that. Okay? To save time, I'm going to tell you right now. This is no. Okay? Oh, let's do the open and close circles first, guys. So negative 2. Negative 2 is not included. 3 is not included, so those don't work either. Now I'm doing all the test values. Negative 4 is a no. Okay? Well, how do I know, guys? I did it. I don't feel like going through all those numbers again. Testing negative 2.5, you get a yes. So what does a yes mean? I'm going to connect them. Okay? Testing a negative 1 is a no. That means don't connect them. Testing a positive 1, I get a yes. What does that mean? I connect those. And then the last thing to check for is, does 4 work? And 4 is a no. Okay, so the only areas that work are here and here. So, what does that mean in set notation? It's any number strictly between negative 3 and negative 2, but not including